Howdy Yags! This is the mini lecture that is the second part of this week's lesson on fossil fuels. After reading chapter 19, watching this video, or reading the transcripts that go with the video, and watching the other assigned videos and activities for this chapter, you should be able to examine how we are reaching further for fossil fuels, outline and assess environmental impacts on fossil fuels, and explore solutions to that, evaluate political, social, and economic aspects of fossil fuels, and specify strategies for conserving energy and enhancing efficiency. While fossil fuels make travel easier, increase our lifespans by providing products that promote or protect health, such as surgical tubing or pharmaceuticals, and increase our material standard of living, they have drastic negative effects on our health, and the environment. Also, we discussed in part one, as we discussed in the part one video, we have already extracted the easy to reach reserves of fossil fuels. So efforts are being made to develop technologies to extract harder to reach reserves or resources. We will consider both of these issues as well as strategies for conserving and enhancing energy efficiency in this video. Because the easily extracted fossil fuels have already been harvested, we now must rely on a number of new approaches to extract more fossil fuels. These methods include secondary extraction from existing wells, hydraulic fracturing for oil and shale gas, offshore drilling in increasingly deep waters, moving into ice-free waters of the Arctic, and exploiting unconventional fossil fuel sources. These efforts will reduce the EROI of fossil fuels because we are having to invest more time, more energy, and more money and more resources into extracting the fossil fuels that remain in the ground. We can expect that as we pursue these options, the cost of fossil fuels will increase and pollution and climate change will intensify. For example, the oil sands in Canada and Venezuela are already increasing available oil, and known deposits of oil shale may contain more oil than all the conventional crude in the world. These oil sands and the oil shale found under federal land in Wyoming, Utah, and Colorado are unconventional fossil fuels we have begun to exploit. Most of the oil in oil sands and oil shale will not be easy to extract. The EROI for oil shale and oil sands is therefore very low. Oil shale's EROI ranges from 1.121 to 4.0 to 1. Oil sands EROI is 3.1 to 5.1. Now let us consider each of the advanced methods for extracting fossil fuels, beginning with secondary extraction for existing wells. Part of the quest for more fuels has been to revisit old sites. When a site is first developed for fossil fuels, it is said to go through primary extraction, which is initial drilling and pumping of available oil and gas. Primary extraction removes the fossil fuels that are easiest to access and therefore the cheapest to harvest. Secondary extraction is when solvents, water, or steam is used to remove additional oil from a site that has already gone through primary extraction. With secondary extraction, materials are injected into the site or into the well to increase pressure and allow the remaining oil or gas to be extracted. While we do have technology to extract some oil with secondary extraction, we lack technology to remove every last bit of oil. Secondary extraction is expensive, and if the cost of oil and gas is too low, the cost of performing secondary extraction is not economical. For this reason, many U.S. deposits did not undergo secondary extraction. However, in the 1970s, the price of oil rose and companies started secondary extraction on U.S. wells. This pattern has continued today. Another method for extracting hard-to-reach or previously unavailable fossil fuels is hydraulic fracturing, or fracking for short. This is a picture of a fracking operation. Fracking consists of breaking rock formations to release oil or gas trapped in impermeable shale. Hydraulic fracturing is used for secondary extraction and to tap new deposits. Fracking has allowed access to previously unusable deposits and and has increased proven reserves and boosted U.S. natural gas production. However, people that live in areas where fracking is taking place have concerns. They often feel they must make a choice between financial gain and impacts to their health and drinking water. Some of the problems with fracking stem from the fact that this industry has been exempted from 6 major environmental laws. Specifically, fracking is not required to comply with the Clean Water Act and the Safe Drinking Water Act. These exemptions are due to what is commonly known as the Halliburton loophole, which is a policy pushed through Congress by former Vice President of the U.S., Dick Cheney, who, interestingly enough, is the former CEO of Halliburton. The Halliburton loophole exempts corporations from revealing the suite of chemicals they use in their fracking injection solution. Fracking is also exempted from key provisions in the Resource Conservation and Recovery Act, the Comprehensive Environmental Response and Compensation Liability Act, the National Environmental Policy Act, and the Toxic Release Inventory under the Emergency Planning and Community Right to Know Act. Impacts of fracking are not yet understood completely, but some of the concerns are that chemicals may leak out of drilling shafts and contaminate aquifers. Methane may travel through the fractures and contaminate drinking water. Methane and drilling chemicals may escape into the air, causing unhealthy conditions. An immense amount of wastewater is produced, and wastewater may contain salts, radioactive compounds, and toxic substances. Wastewater from fracking facilities may be sent to sewage treatment plants that are not designed to treat these pollutants. Alternatively, wastewater from fracking operations may be injected into disposal wells underground. While these companies assure the public these disposal wells are not hydrologically connected to groundwater resources, this may not always be entirely accurate. And finally, fracking is suspected to cause an increase in seismic activity, including tremors and earthquakes. Today we drill for oil and gas both on land and at sea. Offshore oil drilling platforms are massive structures that drill for oil or gas below the seafloor on continental shelves. These drilling platforms must withstand wind, waves, and currents. Offshore drilling produces 35% of the oil and 10% of the natural gas extracted in the United States. Shallow offshore drilling has been going on for decades. However, industry is moving into deeper and deeper waters, and this runs the risks of increased danger. In 2008, Congress lifted a drilling moratorium along the U.S. coasts. In 2010, President Obama said vast areas would be open for drilling. Then, British Petroleum's offshore drilling platform, the Deepwater Horizon, exploded. British Petroleum is commonly known by the abbreviation of their name, BP. The Deepwater Horizon oil spill of 2010 killed 11 workers. This spill was the largest accidental oil spill in history. It took 87 days to plug. For 3 months, the Deepwater Horizon's explosion spilled into the ocean. In total, 4.9 million barrels of oil spilled into the Gulf of Mexico. Researchers found that the Deepwater Horizon caused the oil to be let out of the well was the rate of 62,000 barrels of oil a day. The Gulf of Mexico suffered many impacts, including countless animals such as birds, shrimp, and fish died. Coastal marsh plants died, leading to coastal erosion. Fisheries were devastated and fishermen lost their jobs. For months, volunteers and workers paid by BP performed arduous physical labor to clean the beaches, and tourism in and on the coast of the Gulf states saw a dramatic decline. Public reaction to the Deepwater Horizon spill caused President Obama to backtrack. In 2011, he issued a 5-year plan that opened 75% of technical reserves to drilling. Discoveries of oil far offshore are encouraging more deep water drilling regardless of our ability to deal with accidents there. For example, plans are underway for deep water drilling in the Arctic. As ice sheets melt in this area of the world, we can expect to see several countries jockey for position to try to gain access to these waters for oil and gas drilling. Despite the threats of frigid temperatures, ice flows, winds, and waves, and storms, Arctic drilling is still being considered. The proposed oil drilling in the Arctic could have serious spill threats and it could be very difficult to clean them up considering it is in the Arctic. Another environmental impact of fossil fuels is the devastation of coal mining has on the land and water. Strip mining destroys large swaths of habitat and causes extensive erosion. Strip mining can also cause chemicals to run off into natural waterways near a mine. This process is called acid drainage and occurs when newly exposed rock surfaces react with oxygen and rainwater to form sulfuric acid. As if sulfuric acid wasn't bad enough, this acid runs over rocks and causes heavy metals naturally contained within the rocks to leach out into the runoff, leaving the mine. This runoff makes nearby waterways toxic. Acid drainage is a natural phenomenon, but like many other things, our actions have exacerbated the extent and damage of this process. U.S. regulations require companies to restore strip mined land, but complete restoration is impossible. Mountaintop removal removes tons of rock and soil, destroying an immense amount of habitat and creeks. Loosening of regulations in 2002 allowed companies to legally dump debris from the mountaintop removal process into valleys and rivers below, regardless of the consequences. Recall the oil sands of Canada I mentioned in the Fossil Fuels Part 1 video. Not surprisingly, oil sands development pollutes water. There are also concerns about pipeline leaks for the pipeline that carries oil from oil sands in Canada to the U.S. Consider the impact what a spill might mean, given the fact that the Keystone Pipeline travels over the Ogallala Aquifer, which provides 2 million Americans with water. The pipeline leaks occur due in part to the fact that oil from the sands is more corrosive than crude oil. Extraction from oil from oil sands uses immense amounts of water that become polluted, and that polluted water is held in massive reservoirs. Birds landing in these reservoirs are killed by these pollutants. Also, strip mining for oil sands requires deforestation. Alberta's oil sands were mined 30 years ago and were started to be mined 30 years ago, and they still haven't recovered. Using alternative fossil fuels such as oil sands produces more carbon dioxide than traditional fossil fuels. Specifically, oil sands produce 14% to 20% more carbon dioxide than conventional oil. Shale oil is even more polluting. This slide features figure 19.23 from your book. As you can see, our reliance on fossil fuel is caused by powerful extraction technologies such as ones we've discussed previously in this video, and government subsidies, both of which drive the cost of fossil fuels down. Our failure to develop alternative energy sources and our continual development of new applications of fossil fuels also perpetuates our dependence on these fuels. However, these fuels are being depleted because we have 1, a growing population, 2, are consuming more per capita, and 3, have limited non-renewable supplies, and 4, poor fuel economy and automobiles. Both reliance on fossil fuels and depletion of fossil fuels drive climate change, cause severe health problems. For example, burning coal high in mercury releases the heavy metal into the environment. Mercury then bioaccumulates, poisoning animals and posing a threat to humans. Burning fossil fuels produces emissions that pollute the air and irritate the nose, throat, and lungs and cause cancer. Burning oil and coal produces sulfur dioxide and nitrogen oxides. Fossil fuels also contribute to smog formation and acid deposition. Burning coal emits a variety of pollutants such as sulfur, mercury, arsenic, and other trace metals. However, there are some things we are doing to reduce these detrimental impacts of fossil fuels. To begin, we have developed clean coal technologies, which are technologies, equipment, and approaches to remove chemical contaminants while generating electricity from coal. For example, scrubbers can chemically convert or remove pollutants such as sulfur dioxide or nitrogen oxides from coal emissions. Another clean coal approach is to dry coal with a high water content so that the coal burns cleaner. Another approach is gasification, which is when coal is converted into a cleaner synthesis gas, also known as syngas or synfuel, by reacting it with oxygen and steam at high temperatures. While clean coal technologies have reduced pollution, clean coal is still a dirty way to generate power. It is not a surprise that oil and gas extraction modify the environment. More than drilling is involved in developing oil or gas. Roads, exploration, infrastructure such as housing, roads, pipes, and waste piles are all required for drilling. Collection ponds are used to store toxic sludge, and drilling pollutes soil, air, and water and fragments habitats. However, there is one technology that has been developed to reduce the environmental impact of drilling. Directional drilling is when drillers bore down vertically into the ground, but when they reach their preferred depth, they can change direction and then begin drilling horizontally. This allows them to drill for oil or gas without having a drill pad directly above the oil or gas reserve. This technology reduces the number of drill pads required for an area, and therefore the surface footprint of the drilling area is smaller. For many reasons, mostly related to either our health or the health of the planet, we need to minimize the extent that we use dwindling fossil fuel supplies. We can achieve this by a combination of energy efficiency and energy conservation. Energy efficiency is obtaining a given amount of output while using less energy input. Considering a good deal of energy is lost as waste, we can use technology improvements to improve energy efficiency. Energy conservation is quite simply reducing energy use. Energy conservation results from behavioral choices. By being less wasteful and prolonging the fossil fuel supply, we can avoid some difficult energy decisions. The United States uses twice as much energy per dollar of gross domestic product as most other industrialized nations. Not surprisingly, Europeans use less energy per capita than the United States. We have cut energy use, but there is still room for gains in efficiency in the future. Individuals can make conscious choices by driving less, turning off lights, and buying energy-efficient appliances. We as individuals can conserve energy through our personal choices of how we use energy and by using efficient technologies. For example, energy-consuming devices can be made more efficient. Cars and power plants lose 2/3 of their energy as waste heat. This waste can be reduced with cogeneration, which is using excess heat from electricity generation to heat nearby buildings and produce other kinds of power. Cogeneration can nearly double the efficiency of a power plant. Improvements can also be made to reduce the energy needed to heat and cool homes. In this slide, you can see a thermal image that shows the heat loss from homes. The red colored home indicates that heat is being lost from the house, while the greenhouses are houses that have better insulation that allow the homes to conserve heat and not let it escape. Notice the heat loss for all the houses is greatest around the doors and windows. Vegetation around a home, as well as passive solar energy, can also conserve energy in a home. Passive solar energy is when buildings are designed to maximize absorption of sunlight and thus natural heat during the winter and to keep the interior cool in the summer. We will discuss passive solar more when we study new renewable energy alternatives. Many consumer products are now more efficient. Energy-efficient lighting can reduce energy by 80%. Many governments are phasing out incandescent lights in favor of more energy-efficient compact fluorescent bulbs. Federal standards and the Energy Star program have reduced electricity used by appliances. If all Americans bought energy-efficient appliances, energy expenditures would be reduced by $200 billion. Automobiles provide the greatest fossil fuel conservation opportunities because conventional automobiles are very fuel inefficient. Of all the energy in the gas put into the car, only about 13 to 14% actually moves the car forward. Nearly 85% of the useful energy is lost, primarily as heat. Alternative technologies such as electric cars, hybrids, and hydrogen fuel cell vehicles are more efficient options than traditional cars. Hybrid cars have high fuel efficiencies. Some of the top U.S. hybrid models are the Toyota Prius, the Chevrolet Volt, and the Ford C-Max. Top models of electric vehicles include the Chevrolet Spark EV and the Fiat 500e. The Ford C-Max gets an estimated 42 miles per gallon, or MPG, and 37 MPG on the highway. The Prius gets an estimated 51 miles to the gallon in the city and 49 to the gallon on the highway. The Chevy Volt gets approximately 42 miles to the gallon. Compare this to a Ford Focus, which is a conventional car, which only gets 26 miles to the gallon. According to the U.S. Energy Information Administration's last annual energy review, the transportation industry consumes 71% of all the petroleum resources of the U.S. and is the second largest energy-using sector behind only the electric power generation sector. Considering this and what we previously mentioned about the energy inefficiency and traditional vehicles, automobile fuel efficiency is a key place where we can conserve energy. We have a history of attempting and in some cases succeeding in obtaining greater energy efficiency in vehicles. In 1973, the Organization of Petroleum Exporting Countries, or OPEC, stopped selling oil to the U.S. OPEC is largely run by Arab nations, and most Arab nations oppose the support the U.S. provided Israel during the Arab-Israeli Yom Kippur War. In response to this embargo, the U.S. government tried to reduce gasoline used by maintaining an increase in fuel efficiency and decreasing speed limits to 55 miles per hour. These measures worked, reducing our dependency on foreign oil and our greenhouse gas emissions. However, these conservation initiatives were abandoned over the next 30 years as market forces supported lax policy with fuel use. Essentially, people lacked the economic incentive to conserve fuel because gas prices dropped. Speed limits rose, research for alternative energy sources fell, and policymakers failed to raise the corporate average fuel efficiencies, or CAFE standards, CAFE, which these CAFE standards set the MPG, or the miles per gallon standards in commercial vehicles in the U.S. New vehicle average efficiencies fell from 22 mpg in 1987 to 19.3 mpg in 2004. New vehicle average efficiency fell from 22 mpg in 1987 to 19.3 mpg in 2004. MPG standards climbed to 22.8 mpg in 2011 after Congress mandated average fuel economy of 35 mpg by 2020. In 2009, the Obama administration tried to improve fuel efficiency, stimulate the economic activity, and save jobs by enacting a program that would work together with automakers to boost average fuel economies to 54.5 mpg by 2025. It is estimated that this program would have saved consumers $11.7 trillion at the pump over the life of the program, and that a family could save $8,200 in fuel costs compared to a vehicle that did not meet the fuel economy standards set for 2025. Over the life of the program, Obama's fuel economy standards are estimated to save 12 billion barrels of oil and eliminate 6 billion metric tons of CO2 pollution. Here's a graph that shows what the MPG standards for a vehicle has been historically and what it will be as the Obama fuel economy standards are phased in. The last thing I want to mention is that we can reduce emissions. While this seems like a daunting task, if we break it up into smaller steps, it is much more manageable. Here you see a figure 18.27 from your book that shows 15 strategies that will each eliminate 1 billion tons of carbon each year by 2050 if deployed at a large scale. If we achieve just 7 of these 15 aims, we would stabilize our emissions. If we achieve more, we will reduce our emissions. These actions include double the fuel economy of cars, which, compared to the MPG of 1970, we will achieve with Obama's fuel economy standards of 2025. Cut the miles driven by cars in half. Maximize the efficiency of all buildings. This is where LEED certification comes in. Double the efficiency of coal-powered plants. Cogeneration can help achieve this. Switch from coal to natural gas at 1,400 plants. natural gas is a cleaner burning than coal. Capture and store carbon from 800 coal plants. This is referred to carbon capture. This is referring to carbon capture and carbon storage, or carbon sequestration. Carbon capture consists of capturing CO2 emissions, converting the gas to a liquid, and then sequestering it, that is storing the liquid in the ocean or in underground geological formations. Capture and store carbon from 180 synfuel plants. Triple the world's nuclear capacity and increase ethanol production by 50 times. We will discuss nuclear energy and ethanol when we discuss conventional energy alternatives. Increase hydrogen fuel production 10 times and increase wind and solar capacity by 50 and 700 times respectively. We will examine these energy sources when we discuss new renewable energy alternatives. Halt tropical deforestation and double reforestation efforts. And finally, adopt conservation tillage on all croplands. I hope this last topic leaves you on a slightly positive note. There are things we can do to fix the problems we have created for ourselves. And the good news is that currently we have the technology to make these changes. The question is a matter of will. You can make a difference, and you can, as you proceed through your life, you can help to solve this problem through the choices you make and the policies you support. This concludes the second mini lecture on fossil fuels. If you haven't already done so, please watch part 1. Please review the weekly outline and complete the activities for this week per the schedule set forth in the outline.